Example 2, a track coach wants to determine an appropriate heart rate for our athletes during workouts. He chooses 5 of our best runners and asks them to wear heart rate monitors during the workout. In the middle of the workout, she reads the following heart rates for the 5 athletes. Which is a better measure of the average, the mean or the median? So let's just calculate it. Okay, the mean, okay, 130 plus 135 plus 140 plus 145. You could enter in your calculator doing the, okay, so 130, whoops, 130 plus 135 plus 140 plus 145 plus 325 divided by 5 is 175. The median, we have them in order: 130, 135, 140, 145, 325. Check, 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 check. The median is 140. So now, which one, when you're thinking about the average, you're going to think which better represents what's going on in the middle of this distribution? Which one's a better representation? And so in this case, I would say the median is better because it looks like this right here appears to be an outlier. Now, it could be somebody who just had a really crazy mishap during the workout, or it could be just a misread on the monitor. Okay, but it's an outlier. It doesn't fit with the rest of the data. And so when you have an outlier, what it's gonna do, it's gonna strongly impact the mean. It's gonna make the sum of the values that you add up much larger, or it could be smaller if it's a small outlier, and it's gonna have a significant impact where the median, you see the median's just the middle. So the median's not really impacted much by that. So I would say the median, let's first off, this data set has an outlier. So let's establish that first. This data set has an outlier, 325. Okay. And it might say which would cause the mean to increase significantly, but does not impact the median. And so, like, it doesn't really have an impact on the median. So I would say that the median, thus, the median would be a better representation of the average in this case. There's going to be some cases where the mean's